Okay, matrices. So this is a matrix, and how it works is we have to talk about rows and columns. So first of all, do you understand what a row is and what a column is? A row is like that, and a column is like that, right? So we always measure matrices like this. This is a 2, because it has 2 rows, by 5. So it's a 2 by 5 because it has 2 rows and it has 5 columns. So I always remember Rapid City. I don't know, do you guys know what Rapid City is? No, it's a town in Manitoba, right outside of Brandon. Anybody? No, no. What about in South Dakota? Rapid City, South Dakota is also a place. No, don't know any of your geography. What monument, big iconic thing in the States is in Rapid City? Mount Rushmore. Have you been there?
It's the only thing in South Dakota.
It's the only thing. I think I've been there like 8 times or something. Okay. Or if you can't remember that, my son's name is Reed Carter. I don't know. Whatever makes you think of something. Rows, columns. Okay. So A24 means which of these digits is in the second row, 4th column? Which position would that be? Second row, 1, 2, 3, 4. This one, right? A 5. 1, 3. What's in the first row, 3rd column? First row, 3rd column. -7. Okay, so that's a basic positions of a matrix, knowing that it's rows, then columns. Okay, adding and subtracting. So to add and subtract, you have to have matching matrices, as in the same amount of rows and columns. You can't add if they don't. Okay, so we have to do position 1, 1. So what's 3 plus 4? 7. And then you're going to do position 1, 2 together. So there's a 1 and a 2. So 3, 8. Okay, keep going. Okay, so this one, I'm thinking, what do I need to add to make that? So I would need 5 plus what to make 11? That's what I'm going to do. So 6. 1 plus what to make 5? So I need a 4. This one might be a little tricky. Got to think about it. 4 plus what gets you to a -3? -7. Okay, go ahead. Okay, so this was just me saying if you want to add and subtract, then same order. You have to just have everything the same rows and columns. Okay, scalar multiplication. So this is just a coefficient. So this times is everything. So then times by 3. So 12, 15, 6. Okay, so this would be more of a test question that I would give you here. So here it says find 2a minus 3b. So this is what we're going to do. We're going to times a by 2. Can you write that down? We get a 4, 10, 14, negative 4, 8, and 6. Times that one by 2. Minus 3 times b. So we got to times this one by 3. So 12, negative 6, 15, 0, 27, 15. Okay, so there's the scalar multiplication. You guys can stop me if I did something wrong here. Okay, and then we're supposed to subtract. So now I'm going to go 4 subtract 12 in the first position. So negative 8. Be careful here. 10 subtract negative 6. Positive 16. Right, so that would be kind of a test question, something like that. Scalar multiplication and a subtraction together. Okay, so figure out what the coefficient is that's missing here. So what did I times this by to get to that? The coefficient would have been a 2. Okay, so now we're going to get into matrix multiplication, how to multiply one matrix by another one. Okay, so here's what's going on. So team A has 5 wins, 3 ties, 2 losses, and then team B. And then when you score points, you get 2 points for a win, 1 for a tie, and 0 for a loss. Okay, so I'm going to go like this: 5, 3, 2, 7, 2, 1. That's going to be my first matrix to represent the team's scores. And then the points are going to be a 2, a 1, and a 0. Okay, so what order is this? What kind of matrix is it? A what by what matrix? So how many rows, how many columns? It's a 2 by 3. That's what order it is. It has 2 rows and 3 columns. And this is a, how many rows? 3 rows and 1 column. Okay, to multiply matrices together, here's what has to happen. Those have to be the same. The insides, like that, have to be the same. And your final matrix will end up being a 2 by 1. So that has to happen to do it. Okay, so here is what's going to happen. So the final one is going to have 2 rows and 1 column. It's going to look like this. It's going to have 2 rows with 1 column. So your first combo is you're going to do row 1, column 1. Row 1 of that, column 1 of that. And then you're going to do row 2, column 1. I don't know, does that make sense if I say that? So I'm going to be doing this times this to start. Okay, so here I go. Multiplying makes 10 plus 3. Do you see where I'm matching? 10 plus 3 plus 0. Do you see what I did there? I went match, match, match. That's why they all have to have the same in them. Match, match, match. Do you see my answers? There's the 10, 3, 0. Okay, that's good. Now I'm going to do that. Row 2, column 1. Okay, so matching this is going to go 14, 2, 0. 14, 2, 0. Okay, and obviously I did a very simple example. You can see if they get 5 wins, that's 10 points. And then 3 ties, so they got 13 points, right? And then this one, 14 points and 2 more points. Oh, 16. Didn't see that. Okay? Okay, so here's kind of a summary. So this is what I did. If the first one is that, the second one is that, we knew that this has to match. And then our final will end up being that. Okay, so here we go. This is a 3 by 3. And this has 3 rows, 2 columns. So my final is going to end up being 3 rows and 2 columns. So here's what you're going to be doing. Row 1, column 1. Row 1, column 2. This one is going to look like this. Row 2, column 1, row 2, column 2. So do you see how I'm doing every kind of combo? Okay, so you can see the positions. This is in row 1, column 1. This is still in the first row, but now it's in column 2. Okay, so what does this look like for matching up? So my first thing like that is going to look like this. Row 1 with column 1. You see how I've highlighted? Row 1, column 1. Row 1, column 1. Okay, so we're going to match all these multiplying. So we're going to get a 2, and a 12. You see them? 2, 2, 12. Okay, now I'm going to go here. I'm going to do row 1 with column 2. So that would look like this. Row 1 with column 2. So if you follow my fingers here, I'm going to do like this. 4, 10, 8. 4, 10, 8. Okay, shall I let you try the next combos? Is that okay? So row 2. So here's my circled pen here. This is row 2 and column 1 together. Okay, how did you do? How did I do? Maybe you can rate me if I made any mistakes. Okay, I want you to set this last example up very similar to our wins, ties, and losses. Okay, so order A has 5 chocolate bars, 6 chips, 7 drinks. And then B did 7 chocolates, 2 chips, 9 drinks. And then there's the cost of chocolate, chips, drinks. Okay, so you can probably understand this math. 5 chocolate bars times 90 cents. That's what I'm doing in my matrix. 6 chips, 70 cents each. That's what I'm doing in my matrix. So I'm going to do this times this. Match, match, match. Go ahead. So 5 times 90, that is 450. 6 times the 70 is $4.20. And then 7 times the 50 should be $3.50. Okay, now I'm going to do row 2 times column 1. So 7 times the 90 is $6.30. 2 times the 70 is $1.40. And then 9 times the 50 is $4.50. Oh, is that the same? Anybody else get the same spending? Okay, so you see the matchup? You got to follow, follow, follow with your fingers like that. Okay, last thing. Identity matrix multiplication. Okay, so this is a 3 by 3 and this is a 3 by 3. So those match and our final is going to be a 3 by 3. Okay, so how do you start? You do row 1, column 1. That's the start. So we're going to get 4, 0, and 0. Okay, next, what position is this? This is row 1 with a column 2, right? Row 1, column 2. So here's my matchup. 4 times 0, so 0, 5, 0. Now I'm in row 1 and column 3. So I got to match row 1 and a column 3. So row 1 on this, column 3 on that is going to match 0, 0, 7. Okay, so what are you going to do when you get to this? This is going to be into row 2, column 1. So row 2 and column 1 is going to make a 5, 0, 0. Smack dab in the middle is the second row, the second column. Second row, second column makes 0, 9, 0. Any predictions on what's happening here? It's just going to be the exact same. So that's why it's called an identity matrix. So this is our math version of timesing something by 1 and keeping it the same as an identity. Okay, so you keep this the same, and you have nothing else. So you see how it's diagonal. Okay, so identity matrix is what that ends up being.